Answer each of the following questions related to the unit circle. In Part A, is sine theta equals 2 possible? Explain using the unit circle as a reference. The radius of the unit circle is 1. The bottom of the unit circle has a y value of -1, and the top value is +1. If the value of sine theta was 2, the unit circle would have to intersect the line y equals 2 at some point. The circle and line do not intersect, so it is impossible for sine theta to equal 2. Now we'll move on to Part B. Which trigonometric ratios are restricted to a range between -1 and 1? Which trigonometric ratios exist outside that range? On the unit circle, we can see that both sine theta and cos theta are confined to values between -1 and 1. For the rest of this question, we will refer to the results of example 7. Bring up the result from example 7a. Using the identity secant theta equals 1 over cos theta, we can find the value of secant theta. Secant theta is always smaller than -1 or greater than 1. Now bring up the result from example 7b. Using the identity cosecant theta equals 1 over sine theta, we can find the value of cosecant theta. Cosecant theta is always smaller than -1 or greater than 1. Now bring up the result from example 7c. Using the identity tan theta equals sine theta over cos theta, we can find the value of tan theta. Tan theta can be any real number. Bring up the result from example 7d. Using the identity cotan theta equals cos theta over sine theta, we can find the value of cotan theta. Cotan theta can be any real number. Now we'll summarize our results. Cos theta and sine theta will always have a value between -1 and 1. No matter what angle is used, the sine and cosine values always stay between -1 and 1. Secant theta and cosecant theta have values smaller than -1 or greater than +1. No matter what angle is used, the secant and cosecant values will always be less than -1 or greater than 1. Tan theta and cotan theta have values that can be any real number. As the examples show, the tan and cotan of an angle can be any real number. Now we'll move on to part C. If sine theta equals -√2 over 2 exists on the unit circle, how can the unit circle be used to find cos theta? Find points on the unit circle where the y-coordinate is equal to -√2 over 2. Two angles satisfy this condition, 5 pi over 4 and 7 pi over 4. Therefore, there are two possible answers for cosine theta. Cos theta equals -√2 over 2 from the point at 5 pi over 4, and cos theta equals √2 over 2 from the point at 7 pi over 4. Now we'll move on to part D. If cos theta equals 3 over 5 exists on the unit circle, how can the equation of the unit circle be used to find sine theta? The equation of the unit circle is x squared plus y squared equals 1. The x-coordinate of the unit circle is cos theta. Plug in 3 over 5 for x. Square 3 over 5 to get 9 over 25. Subtract 9 over 25 from both sides of the equation to isolate y squared. Get a common denominator of 25. This gives us y squared equals 16 over 25. Square root both sides of the equation to get y by itself. This gives us y equals positive or negative 4 over 5. The y-coordinate of the unit circle is sine theta, so there are two possible values for sine theta. Two angles are possible, at 53.13 degrees and 302.70 degrees. Now we'll move on to part E. If cos theta equals 0 and theta must be between 0 and pi, how many values for sine theta are possible? Find the points where cos theta equals 0. Two angles satisfy this condition at pi over 2 and 3 pi over 2. We have the restriction that theta must be between 0 and pi, so reject the point at 3 pi over 2. There is only one possible answer, sine theta equals 1. In part C and D, no restrictions were present, so we got two answers. In part E, we had a restriction and got one answer. As we proceed through the trigonometry unit, there will often be restrictions on trigonometric equations that limit the number of potential solutions.